All right, everyone, thank you for joining us once again. So we are hanging out at our local Johnstone Supply to discuss new control boards and new motor technologies. So we're hanging out with Jim Foltz from White-Rodgers. How are you today?
I'm doing great. Thank you for having me. This is a pleasure being here and being able to go through all this great technology we have nowadays.
Yeah, so we spent a lot of time talking about technologies and innovations. We just came back from the National HVACR Education Conference where it was all about new technologies and innovations. We spent a lot of time talking about ECM motors, inverter technology for compressors. So what we got to start thinking about too is replacement parts. Like, I'm a universal parts guy. I like keeping parts that are very flexible so that I have lots of opportunities to, utilize universal parts out in the field. But we've also been moving into a lot of ECM motors in our gas furnaces, right? And our air handlers as well. So when we start talking about universal replacements, we have to really start taking into effect that there's a lot of technologies out there. So we're going to talk about a new board today. We're going to talk about the new 50M56X-843 universal replacement board, but it'll work with PSC motors and some of our ECM motors. Is that correct?
Yes.
All right, so when we talk about ECM motors, we spent some time with Chris Mahaly from Regal Rexnord talking about the different types of voltages going into ECMs. So we have in our earlier stages, and especially in our X series motors, we would have like the 24-volt AC, but we're starting to move into some PWM, pulse width modulation, DC signals, going even into some of our constant torque motors. So how do we address that, and what should we be looking for when we're talking about universal boards with ECM motors, like this particular gas furnace that we have here?
Hey, that's a great question. And what we have with the 50M56X is when we were designing this, we were looking at different types of voltages that ECMs receive. And what we found was early on, most of our constant torque ECMx motors would take this 24-volt AC signal.
Right.
Well, somewhere around the time that we actually saw the transition to ECMx motors in new manufacturing, the July 2019 mandate.
Transition, right.
And with that change, motor manufacturers also were looking at the signal that their motor would take, and that signal from that point forward, most across the board, most of these motors will take a DC signal, and that DC signal can be anywhere from 9-volt DC all the way up to 18-volt DC.
Right.
And that DC signal will work on even old control boards that would have sent a 24-volt AC signal to the motor. The motor also will receive that DC signal and turn the motor on that way. So
Sure.
When we designed the 50M56X, we designed it with the idea that we were going to send out that DC signal for all ECMXs, and it would work across the board with all of them. Now, it works great. The problem is, if you're a technician and you're used to 24-volt AC and that's all that's been trained, exactly,
Right.
that's all that's been trained up to this point, then it's like, oh, whoa, wait a minute, I got a bad new board because it's not sending that 24-volt signal out. And what we have today here on this furnace, we have a Goodman gas furnace, and it has on it this actual 6-pin plug, that inline plug that plugs the ECMx directly into it. And one of the things that we want to go through today in doing a board replacement is to actually check the voltage signal out of the old board so that we can see if it is 24-volt or most of them are somewhere around 9 to 10 volt DC.
Sure,
and
absolutely.
So that's what we're looking at here today, to be able to show you that this board with this inline plug is more than likely a 9-volt DC signal.
So to verify whether we have a 24-volt AC or a DC voltage for our fan speeds, we're going to apply power to the furnace. We're going to set the thermostat for a call for fan or call for G, and then we're going to check. Now let's start out with AC voltage, because one of the common misperceptions is that if I don't have my 24-volt AC, if I have a partial voltage, I must have a bad board. So we're going to show that that's not really the case. So we're going to look at this board. We're going to test from common to T1, which is the fan speed that we currently have, and we'll see that we have a partial AC voltage, 12.2, only about half of our AC voltage. So a lot of times we would assume that this is a bad board because it's not supplying appropriate voltage. Not true. So we could check through the other terminals and we'll see that there is no AC voltage on the other fan speeds. But what we're actually looking for on this particular manufacturer's board is that it has a DC voltage for the fan control of our ECM motor. So if we put our meter on volts DC and we go back to common again, we're going to find that we have that low voltage DC, 8.28 volts on T1. So we're not using 24 volts AC like we traditionally thought of on our constant torque ECM motor. We are truly using a DC voltage onto terminal T1 in conjunction with common for this particular fan speed. If we were to change the fan speed, say we introduced a call for cool, it would actually move the DC voltage to a different terminal. Now, for this particular furnace, we're going to use the same manufacturer with a different model, and we're going to also check our communicating voltages, because we're talking about a constant torque ECM, but remember, not all constant torque ECMs use the same type of voltage. When we looked at our previous model, we had a DC voltage. So we're going to, this time, check both. So we're going to turn power on to the unit. We are going to set our meter to volts AC to begin the process, and we're going to check the voltages from common to T1 again and see what we have. Now we have 24 volts AC versus the DC voltage that we previously had. So we're just going to run through the pins, double check that we don't have any other voltages being applied to our motor speed taps, and we'll go ahead and put our meter on volts DC just to check, but we positively have a 24 volt AC signal on this particular board. If we were to check from common to that same T1, we might see a little residual voltage in there, but our actual ECM fan speed tap voltage is 24 volts AC. So even though we have the same 6-pin connector on both furnaces, one is using a 24 volt AC signal, one is using a approximately 8 volts DC. So you can have a combination of both, but we can now utilize a board that can function with either one of those signals. And so when we were talking to Regal Rexnord about that, it was because many of the equipment manufacturers needed to decide how they were going to program. So our motors from the manufacturer isn't programmed. It's not until we get to the equipment manufacturer that they design the ramp profiles and the programming for it. So some are using the 24 volt AC, some are using the pulse width modulated DC voltage. Now another interesting thing about this board is that previously we would have a variety of harnesses that we needed to utilize, and that has changed with this board. So tell me a little bit about that.
So, well, let's start with the pin for that motor.
Sure.
And one of the additional potential that is out there with this inline 6-pin is the fact that some of these motors now will take a voltage signal from multiple pins at the same time. Yeah. So you no longer have a 3 or a 4-speed blower motor. You can have a 9-speed blower motor, and only on 6 wires. Well, you're sending
you got combinations
out. So that's another aspect of being able to look at the constant torque and to know how to plug those wires in to make sure that they're each plugged into the right terminal rather than having individual terminals. Now we have an inline plug. The same thing with our main plug here. We have a 12-pin Molex plug here now.
Pretty common.
Early on, back in the day when we were starting.
Yeah, when we first got into this. We won't say how long ago, but it's been a little while.
Yeah. There was no Molex plugs on those boards.
Everything was plug and play.
Everything was 1/4-inch spade connector for every single circuit. You plugged in your limit circuit, you plugged in back in the day, I don't even think we had pressure circuits on some of those.
Yeah, a lot of those were tied through individually, sure.
And well, it was before we had induced draft furnaces as well. So, and if you want to go back a step further than that, for even the fan itself had a bimetal mechanical thermostat that stuck in the heat exchanger, and that's exactly what was used to be able to turn the fan on once the heat exchanger got so hot. That's all been digitally changed nowadays. It's all done through timings through a circuit board. And rather than having an increased potential for error of miswiring a furnace,
Sure.
manufacturers started putting these Molex plugs, these multiple pin plugs on. We started out seeing 6-pin plugs and 9-pin plugs. And today, a lot of manufacturers are using what we see on this, the 12-pin Molex plug. It's running the limit circuits. It has the pressure switch circuit in there. Sometimes it has the flame sense circuit in there.
Right.
And sometimes the 24-volt power is going in through that plug as well. So one plug and you have everything tied together. It's faster as well as more accurate. You're not having to worry about miswiring something. And
Right.
so that's kind of the evolution we've seen as we've seen these boards with the low voltage side. Those Molex plugs are working pretty well. On the high voltage side, we're seeing a little bit of that. Some manufacturers will use a 2 or a 4-pin Molex
that
plug
quite a bit, yeah.
for the hot surface ignition and the inducer.
Right.
And having one plug for all 4 wires rather than individual spade connectors on those as well. So that's one of the ways that we've seen a transition into making boards easier to replace. And going to the 50M56X that we're going to put in here today, we have on that board all of the different types of Molex plugs that
the potential combinations
that can go for over 550 SKUs
Right.
Of different boards that are compatible. That's just plug and play. No longer need an additional adapter harness or anything of that nature. And we can talk to that as we go through the install process.
Yeah, because it's very interesting. The actual wire connections on those Molex plugs really depends on the manufacturer.
Correct.
So you could have your limits, you could have your flame rectification, you could have a variety of things in different combinations. So you've designed the board so you don't have to have the adapters, because previously we used the adapters depending on different manufacturers. Now you're actually looking at those signals coming in, so you've traced all the different combinations.
Correct.
And so the board is actually using smart recognition to see what those signals coming in should be. And it goes, oh, I know what you are.
Yeah.
But we also have to be very cognizant that we don't have previous issues, that we didn't misdiagnose a board before we put a new one in, right?
Absolutely. And that's one of the things that's been an interesting challenge with the release of this board. And thanks for the lead-in on that. That's awesome. So the auto harness configuration process occurs whenever you put the 50M56X in. For the first time, you power it up, and it will send signals out. There's 5 different multi-pin connectors there for the low voltage systems. It will send signals out on the ones that would potentially be the output signals for a limit circuit.
Sure.
And it will look for, on all of those plugs, one of those signals coming back.
Yeah.
Once it gets that signal back, it knows, hey, this is the right harness, so we don't have to power any of the other 4 harnesses. We can just now power this one harness, and we know that that's the output and input of the limit circuit. Next, we're going to go and we're going to test and see where the igniter is.
Oh, yeah, sure.
And so most of these, we're going to send that 120-volt signal to the igniter, and the igniter has multiple different options of plug-ins on that. It's somewhat taken to a lower number from the fact that once you know the plug-in for the low voltage, you know what kind of combination you're going to use on the hot surface igniter and blower inducer.
Oh, yeah, absolutely.
So with that, you start testing that. You send that 120-volt signal out. It's going to look for resistance.
Yeah,
and
makes sense.
And if it sees that there is at least 75 to 100 ohms on that circuit,
for our igniter,
then it says, okay, this is the
my igniter circuit.
And with that, if it's a combination plug, then it says, okay, so this other one is the inducer motor, and it sends power to the inducer motor. Well, the inducer motor has to turn on, and once it turns on, then it closes the pressure switch. Now we're going back to that major low voltage pin, in which we've sent power to the pressure switch. Now we get a signal back from the pressure switch. And you know, this has taken us how long to explain all this?
Right.
It does this all in 10, 15 seconds.
Isn't that crazy?
To go through all of those checks. So, so guess what happens if you said, oh, I must have a bad board, and you put the new board in, and it was really the pressure switch.
Exactly. It doesn't recognize the combination.
Or it was the igniter. Or you had an open limit.
Yeah.
Any of them.
Oh, sure.
If any of those are open, during that auto harness configuration, it sends an error code back that says
something's not right here.
It couldn't auto configure, but it doesn't tell you exactly what.
You
need to say, okay, if I'm getting this error code, which on the 50M56X is an E41, if I'm getting an E41 auto harness configuration error, then I need to start looking and seeing hey, there's something else in this furnace that could potentially be the issue, and I need to check that igniter. I need to check the inducer motor, the pressure switch, the limit circuit, make sure that everything's good on all those. Because if in other words, for the auto harness configuration to configure properly, it has to be going in a furnace that the rest of the components are functioning the way they should.
I like that. So we're actually starting to reduce false warranty, because it could have been another board, and we could have been an OEM board. We put an OEM board on. Man, this thing still isn't working. Must still be the board, because we didn't do a proper troubleshooting. So now we're actually going to recognize, hey, we've looked at all of these different potential combinations of OEM pathways, sequences of operation, and none of these sequences fit. So therefore, something is incorrect in the sequence of operation. Go find that, and then I'll work properly for you.
Yes.
Dude, I like that.
Absolutely. So it's the idea is, if everything is functioning properly, and you actually power it up, it will tell, okay, this is the harness configuration.
Wow.
And then it requires that twice to lock in that harness
to make sure.
So it's like, well, how do I get that second harness configuration lock-in while I'm there? Well, typically, when you're testing the board the first time, you have the door switch closed. And that's the first time you're going through.
It recognizes
the
24
auto,
volts AC.
The configuration. Well, then you disconnect your door switch cover that you've put on there while you're doing it, and then you actually install the door. When you install the door, that's your second power-up. It goes through that process while you're putting the door on.
Verifies it that second time.
And so when the technician leaves the job, it's locked into that harness configuration.
Nice.
And the question is that, well, if we have this universal board and we lock it into that, can we ever use it on a different furnace?
Oh, it's an interesting question.
And the answer is yes.
No kidding.
Can. Wow. There is, and we'll get to that a little bit later. With the White-Rodgers Connect with our NFC technology, and you can near field communication. You can actually do setup on your phone for the different fan timing settings on this.
In case we need to adjust the fan timing.
And in those adjustments, there is the ability to reset the harness configuration
back to original OEM specification.
Well, it's actually clearing the harness that was in there.
Absolutely.
So that when you put it into something new, it starts that sequence of searching for which furnace is in again. Man. So you do have the ability to reset that if you choose to pull it out and put it in a different piece of equipment down the road. And an example of that would be, a homeowner's got a furnace. It's old. It needs to be replaced, but it's -10 outside. And they need heat for the weekend. You can put this board in, get them heat, give them their
get it up and running
bid proposal for replacement equipment, and then they say, hey, we want to do this. You can come back 2 weeks later, do the install, and that board, which has only been in there for a couple weeks, you now have the ability to pull out, reset it, and utilize it for a same scenario again.
Yeah, absolutely. Another scenario I can think about that. I used to do a lot of warranty evaluations for pieces of equipment, and I always try to keep as many universal parts on my van, just in case I had those scenarios where a piece of equipment was still in warranty. Maybe I didn't have that particular board with me, but I could get the thing up and running. So I got the customer some heat until I could actually get the warranty board and do a proper warranty replacement for that, so that they had a warranty component in that original piece of equipment. That's a perfect scenario for that. So you've got a variety of replacement options, and I'm liking the changes in technology. But if I get an E41 error code when I fire it up, it probably wasn't the board to begin with. It was probably a rollout or an igniter or
pressure switch.
Pressure
switch is almost number one.
The most common
of all of them. Yeah, it is.
So it's a good educational tool. So you fire it up and you get an E41. better get back to the basics.
Yeah.
All right.
Yeah, don't say, oh no, I got a
got
brand
another
new
board.
bad board.
Right.
It's like the E41 means there's something else in there that didn't see the circuitry right, and so yeah, it's time to get the meter out at that point
and start diving in
and start testing stuff.
Okay, so let's dive into this. We're actually going to show a replacement of this board. We'll try to get some close-ups so we actually see the process of that, and we'll take a look at the replacement without all the big bundle of harnesses in here like we would typically see. I'm ready for this. All right. Thanks a lot, Jim.
Yep, let's go.
Okay.
The first thing we need to do is use the White-Rodgers mobile app to make sure that our existing part number is compatible with our new 50M56X-843 control board. So we simply look by name, look by model, and it will let us know if it is compatible. This board is compatible with over 550 different models of control boards, so it's very likely we're going to have a replacement. So let's open up the box and see what we have. We have the complete instructions that we need to get very comfortable with, a new matched igniter, and we have our new universal control board. It may be physically a little bit different in size, but you'll find multiple mounting tabs on the outside and as well as on the back of the control, so that it sits in a very similar position inside of our furnace. Next, we will reconnect all of our existing wiring using the appropriately labeled terminals. Reconnect all of the OEM wires to the corresponding labeled taps on the new control board. To simplify the connection to the existing harness, we have a variety of Molex connectors that are suited for your OEM wiring harnesses. To create a secure thermostat connection to the new control board, a new connector is utilized. Make sure that the wires are clean, stripped properly, and secured into each of the screw terminals that will then be connected onto the control board. Verify that all of the wires are secured properly before connecting.
During initial power up, when you first send power to the control, it will go through the auto harness configuration test, in which it will actually test the limit circuit first, then the igniter, then the inducer, finally the pressure switch, and once the pressure switch circuit is closed, the control knows exactly which furnace that it has been installed in. Now this auto harness configuration will occur twice, once when you first power it up, and then when you remove your door switch and take the power off and close the furnace up getting ready to leave, you power it up the second time, and after that second test it will lock that harness configuration in. Once the board has been installed, go into the White-Rodgers Connect app, tap Connect to Control, and then hold the phone over the control where it will read the device. So the top edge is right in the middle there. Once you actually have the control, the top menu item is going to be Blower Select, and it's currently set on PSC2. So if you hit the plus button, you will switch through PSC2 to PSC3 to ECM. Once you get past PCS2 and PCS3, which are for permanent split capacitor motors, you will get a notification sharing that this ECM setting cannot be updated by the app and must be set up manually on the control after installed, which means this is something that will be manually set up in the control to go to the ECM type of blower. So we will do that right now. So with the option and select buttons, you hit the option button and it will go through the errors and then CR, and we will literally walk through the different settings on here until we get to blower. We will hit blower. It shows PS2. We'll hit change and we will go PS3, ECM 2-speed, 3-speed, 4-speed, 5-speed, which this is a 5-wire ECMx. And then once we get EC5, then we'll go back to the blower, run on around through the settings, and once the settings are back to the standby mode. Once we get to standby mode, we should be set for the blower being set for a 5-speed ECMx blower. During the firing of the heat, the reader out will say HPR. During the fire of the heat, the control will read HPR, standing for heat pre-purge, and the 20-second pre-purge will occur. After the pre-purge, the control will read IGN, indicating that the igniter is turned on, and you will physically see the igniter glow during this process. Once the igniter glows and the gas comes on, it will verify that there was flame present. Should the flame not immediately show, the furnace will go into HIP, or inter-purge, which is a purge cycle to verify no raw gas is left in the furnace when it tries to reignite. After that 20-second inter-purge period, or whatever inter-purge period is set on the control, it will try to ignite again.